So now we're going to have a look at some of our control circuits that actually use ECUs and full electronics to be able to operate. Now before we do, we need to have a look at how CANBUS works. In the good old days, we would have an ECU. When it was one ECU, that was no dramas. It only needed to communicate within itself. When we started to add extra ECUs, as long as they didn't have to communicate to any other ECUs, then we had no dramas. But if we wanted the ECUs to talk to each other, for example, we might want the engine and the transmission to talk to each other, then we would connect them up by wires. Then if we then added another ECU, let's say the brake ECUs, if that needed to talk to, for example, the engine but not the transmission, then the engine would be connected to two modules, whereas the ABS would only be connected to one, as was the transmission. If you then added more, then it got quite complicated. You'd find that, one ECU might be fitted to all of them, whereas some of them might only be fitted to half of them, and then a few of them may only be by themselves or connected to one. And as you can imagine, in the top left hand side, you can see the traditional connections. It gets quite messy doing it that way. And that's where we come into CANBUS. You can see underneath we have a picture of lots of ECUs, the same amount of ECUs, but rather connecting them all up individually, we connect them up onto two wires. We call this the CAN bus. I don't want to go into CAN buses now, but we do need a quick explanation as to how they work. So very briefly, what they do is it allows the ECUs to put messages out to other ECUs, and for those ECUs to then communicate back to them to say, yes, I've got your message and this is the reply. It's a very simple way of doing it, and rather than having lots of wires, we now need to only have two that go around all of them. Now this is crucial, particularly when we start to see vehicles starting to be fitted with 20, 30, 40 plus ECUs. It's absolutely critical that we can have a way of connecting them without fitting a wiring harness the size of a trunk. So this is where the CAN buses come into play, and this is how it works on our vehicles. So previously we said that we have the engine control unit, and the engine control unit can operate the starter motor and control the start of the engine by basically using and controlling the relay, and the ignition switch is separate. If we now swap out a control unit, the engine control unit, and put in another control unit, we need to use CANBUS for it to communicate. So here it is. This is what it looks like in a graphical form. We have over here, this is your engine control unit, so that hasn't changed, but you'll notice that we have changed what's connected to it. It still has the crank speed sensor, still has the relay, but it hasn't got the ignition key fitted to it anymore. Over here we have a vehicle control unit. This doesn't have to be called this, it could be called a body control unit. It varies from manufacturer to manufacturer, and again this is just a generic look at what we've got. So you see here we've got the ignition switch, which again is a manual sensor that tells the vehicle ECU, the vehicle control unit, when the driver wishes to start the engine. When the driver operates that and the vehicle control unit receives a signal from the crank position of the switch, then a signal goes up to the CAN bus, or a message goes into the CAN bus. It communicates that message to the engine control unit to say, hey, I want to start. The engine control unit will then act upon that as long as everything's okay. For example, it will check the crank speed sensor just to make sure the engine's not already running. And then if it's okay, if everything's all right for it to start, then it will then, as we've said before, it will energize the relay. And then the power goes through and the starter motor will begin to crank. Same as before, once the engine starts, the crank speed sensor picks up on the fact that the engine speed has increased past what the starter motor would do, and then the engine control unit de-energizes the relay, which stops the starter operation. Very simple, very straightforward. Now, as you can imagine, we're then going to build on this. So we begin to see our push button starts coming into our vehicles. Now some vehicles has had this longer than others. For example, motorcycles have had push starts for a really long time. Cars, relatively long time now, at least 10 years, and trucks, we're just starting to see trucks coming through now. That's just a general idea. It's not a hard and fast rule, and obviously there's been different manufacturers doing things at different times. Now, this push button start has a problem. If you were to just rely on a push button start, i.e. you get into your vehicle and you push it and the engine starts and you can drive away, then there's no security. We need to have some form of security, and that's what the key gives us. So you did see on some of the earlier ones where you had a key to go into an ignition, but you had a push button start because that was the security part of the system. But somehow we needed to move past that because it seems daft that we have a key which we could just turn, and at the same time you then take your hand off and push the button. So we have to move forward from there. So you can see where we've got our vehicle control units, the vehicle control unit that has our ignition key on it, and we have the engine control unit. So we'll add a couple more control units. Now you can see coming in we have our security control unit with an RF or a radio frequency receiver, and we also have a transmission control unit. Now you can notice as well that the CANBUS is now starting to get busy. We're starting to throw out more messages and more signals out onto the CANBUS, and the CANBUS has a way of dealing with this. It's able to prioritize which ECUs are allowed to talk and which ones are allowed to communicate and who's more important than the other. So one can override the other. Now, just to run through how a push button start operates with a vehicle on a CANBUS type system, we have our security control unit. So up here with our security control unit, you walk up and you have a key in your pocket. Now you may push that key, or the security control unit, it may pick up the fact that you have a key in your pocket. Either way, when it gets that signal, the security control unit will disable the alarm, it will allow you to unlock the doors, and it will disable the immobilizing system. Now that's really important because you do not want somebody driving away with your vehicle, and that's what's taken over from our keys. So the driver gets into the car, and you'll notice down onto the vehicle control unit now, we've now lost that ignition switch and it's turned into a push start. So once the driver gets in and comfy, ready to drive, they push the switch, and again it's a manual sensor, so we've got a small amount of current that will come through this switch. Once the driver pushes it, the contacts are made and the control unit receives a signal to say the driver wants to start. It then pushes that message out onto the CANBUS, which is received by the engine control unit. The engine control unit will then decide, well, can I start or can't I start? So before actually operating that relay, it puts out a message. The message would be talking to the security control unit saying, are we okay to go? Is the immobilizer okay? Has it been disengaged? Has the security been disengaged, etc., etc.? And it will put a message back to say, yes, it's all good. It will then also communicate to the transmission control system or the emission control unit. Now, depending on whether you've got a manual or an automatic, for the manual, it might say that the vehicle is in neutral so that you know it's out of gear. Or if it's an auto, the same thing, it will have a neutral or park, so it will know if it's in neutral or park. It will then put a signal back via the CANBUS to say to the control unit, yes, you can start, or no, you can't, I'm in gear. If everything's okay, the engine control unit will then put a small amount of current down to the relay. It will energize, and then again, the vehicle will start. Power is allowed to go down to the ignition switch terminal, and then the starter motor operates as we've previously discussed. So you can see that we're starting to get a bit more complex in our systems. It's not as straightforward as it was before. And we're also having to, just thinking about this bit here, we also need to be aware that if we have a vehicle with a non-start, that non-start may not be because of the starter motor. It could be because of the transmission, it could be because of the security control unit, it could be because of the vehicle control unit. So that we're starting to get a few different things coming into play, which means a non-starting vehicle may not be because of the actual starting system components. We then move on to our start-stop. The start-stop is a crucial piece of software that gets built into the engine ECU, and it's all about emission savings. And by I say emission savings, it's also about fuel savings, up to 8% or more, depending on the circumstances. So it can be quite a significant saving in fuel. It can also be quite a significant saving for the emissions out into the environment. Now we still have all of the control units that we had before, but rather than just adding stuff in and we're having a conventional starting system, we need to make a few modifications. So you can see here now, we've now got an ABS or EBS control unit. We've also got in here, if we look down the bottom, we've got a different type of battery. We have a deep cycle resistant battery and battery sensor. So we've had to do that because the starter motor will start and stop a lot. That can be quite draining on a normal lead acid battery. So we've had to change that out for a better battery. And some vehicles may have 2 batteries as well. We see over here that the starter motor is now a start-stop motor. And what makes it a start-stop motor is that it's now more heavy duty than it was before. So the pinion is stronger, it has a better engagement. The wiring inside, the windings inside are designed so that it can take constant operation, because starter motors can get hot and it doesn't help. So they've had to be redesigned so that they can actually cope with the stop-start of local traffic. You'll also notice that in here, that the brake switch, we didn't mention it before, but the brake switch was on the vehicle control unit. It's now gone to the ABS unit. And we also have a wheel speed sensor in here. Now there are other sensors, there's other actuations that's going on in here. And some of these switches may be part of other control units. Again, this is just a generic overview as to how it works. All systems are slightly different and they operate in slightly different ways. There's also lots of different sensors to do other things. But again, I've tried to keep this to the sensors that will control the stop-start. So on this one here, when we get into the vehicle, everything works as it did before with the security system. As we get in, when we operate the control to say I want to start, everything works as it does before. That's when we get in. Start-stop operates when the vehicle comes to a stop. So we're not turning off the whole the whole vehicle. We're only turning off the engine. So up here we have got the wheel speed sensor. The wheel speed sensor picks up the movement of the vehicle. Once it senses that the vehicle's stopped, then the control unit will then put out a message to the engine control unit to say, hey, the vehicle stopped working, you can stop. Now there's a couple of other things that may come into play there. We may also find that the control unit, it may need to be, if it's a manual, it may need to be that the vehicle is in neutral. It may also need the clutch to be up for it to stop. If it's an automatic, then once you've come to a stop, you need to have your foot on the foot brake. And again, we're over here with the ABS system again. Now, this very much depends on your system. They've all got slightly different ways of working. Some of them will stop quite quickly. Some of them will stop after a few seconds. Some of them will stop once you've got your foot down on the clutch and on the brake. Some of them will only stop once it's into neutral. It all depends upon the system. So I don't really want to get into the dynamics that my car doesn't do this, as how you've explained. As I said, they all do it slightly differently. So within here, once you have come to a stop, you're obviously now going to want to go again. That's usually the intention when you're in traffic, to try and keep up with the car or the vehicle in front. So when you come to move off, a couple of things that are going to happen. If you are running with an automatic transmission, the first thing you're going to do is take your foot off of the brake. When you take your foot off the brake, over here the brake switch will then turn off. A message is sent to the engine control unit to say, hey, he's taken his foot off the brake, therefore it's time to get the engine started. It will then operate the relay, start the engine, or operate the starter motor and start the engine. If it is a manual system, it's slightly more complicated. It will possibly, and again, depends on the system, but what you'll possibly find out is that when you go to put it in gear, in other words, when you put your foot on the clutch, then the vehicle will then send a message via the transmission control unit, via the CANBUS down to the engine control to say, hey, they've put their foot on the clutch, and now that means they're probably going to put it into gear and want to move off. So therefore, again, it will start by operating the starting relay and operating the starter motor. So that's a quick run through of how the start-stop system works and how our electronic control units are talking to each other and how they're communicating to be able to achieve our start-stop. So again, I need to stress that all different systems work different ways. This is a generic look through. I'm hoping that you will get the idea as to what's going on within the systems. Some of the systems are quite complex. The software that's used is quite complex. And also it's worth bearing in mind that if you have a start-stop system, then your battery or your starter motor probably is going to be a bit more costly than the normal ones. Just purely because they have to be built stronger than the normal batteries or the normal starter motors. So there are going to be some differences in cost here, as there are going to be differences potentially in weight as well. So just be aware of that when you're lifting the components in and out.